Hello, I am back again for the Calculus BC 2012 practice exam. Today I'm going to be doing part A of the free response questions. And these questions are going to need a graphing calculator, so if you want to solve along, make sure you have that. Alright, so our first question, we want to find the temperature of water in a tub. That's our function, and we have to find W prime of 12. So what we can notice is we have W of 9 and we have W of 15, but we don't have W of 12. So what we can do is we can use the average rate of change from 9 to 15, since 12 is right in the middle of 9 and 15. And we'll get a good approximation for W prime of 12. So let's write that down. W prime of 12 approximately equals W of 15 minus W of 9 over 15 minus 9. So this is just the slope of the secant line from the x values of 9 to 15. And so when we compute that, that'll approximately equal 67.9 minus 61.8 over 6. So this will be 1.017. So that's our approximation for W prime of 12. So now we have to find what this means. And so since we know that W of T is the temperature of water, we know that the rate of change of W of T is going to be the rate of the change of the temperature. So we can say the rate of change of the water temperature over T equals 9 to 15 is 1.017. So that's what that means in the context of the problem. For B, we have to evaluate the integral from 0 to 20 of W prime of T dt. And so how we can do this is we can set up a start plus change problem. So W of 20 equals W of 0 plus the integral from 0 to 20 of W prime of T dt. So now what we can do is we can solve for this part. We can solve for the change because we know W of 20 is 71, and we know W of 0 is 55 from the table. So we can write all this down, and now we can solve for the integral. So the integral from 0 to 20 of W prime of T dt is 16 degrees Fahrenheit. Awesome. So now we have to find out what this means. So since we know that this is a start plus change problem, we can infer that the change part is the integral. So we can write down the change in temperature of the water in the first 20 minutes is 16 degrees Fahrenheit. Cool. So now we're doing C. For 0 is, so between the interval 0 to 20, the average temperature of the water in the tub is 1/20th times the integral of W of T. Okay, so what we want to do is a left Riemann sum here. So let's go ahead and compute that. So our LHS, left-hand sum, is going to equal 55 times 4 minus 0 plus 57.1, 9 minus 4, plus 61.8 times 15 minus 9, and then finally plus 67.9 times 20 minus 15. And so let's compute this. Okay, so what we're going to get is 1,215.8. So that's our approximation for the integral. But now we have to divide by 20 to get the average value, because that's the definition of average value. So when we divide by 20, we get 60.79. So that's our first part of the answer. Now we have to find if this approximation overestimates or underestimates the average temperature. So if we look at the table, we can see that the graph is increasing, and it says it's strictly increasing in the problem. So if we know it's increasing, we can assume the function looks kind of like this. Okay? And so if we take a left-hand Riemann sum, let's say like here, here, and here, we're not going to get over the function. We're always going to be under. And if it was a right-hand sum, it would be over it like this. So what we can say, what we can deduce from this, is that a left-hand Riemann sum will always under-approximate a strictly increasing function. So our Riemann sum here and our average value is going to be an underestimate. So let's write this down. This value is an underestimate because W of t is strictly increasing and a left Riemann sum always underestimates an increasing function. Awesome. Sorry for the bad handwriting, by the way. Okay, so for question 1D, we're given a function w prime of t, and we want to find w of 25. So this isn't really given in the table, but we can make another start plus change problem, and because we have w prime of t. So let's formulate this. So w of 25, that's what we're trying to find. This will equal w of 20, because we know that from the table, plus the integral from 20 to 25 of w prime of t dt, which we can figure out because we have the function of w prime of t. So w of 20, that's going to be 71. Now, using this formula for w prime of t, integral from 20 to 25 of 0.4 root t times the cosine of 0.06 t with respect to t. And that'll give me 2.043. And so our final answer is going to be 73.043. Awesome. And then we can't forget our units, so we'll put degrees Fahrenheit there. Okay, that's question 1. The next calculator free response question is question 2. So we're given a particle with, we're given dx dt and dy dt, and we have to find if the horizontal movement is to the left or to the right. So for this, we just have to evaluate dx dt, because x is horizontal, and see if it's positive or negative. So if it's positive, it's going to be to the right, and if it's negative, it's going to be to the left. So dx dt at t equals 2, this will equal root 4 over e squared, which equals 2 over e squared, which is greater than 0. So since dx dt is greater than 0 at t equals 2, then the particle is moving to the right. So now we have to find the slope. So let's move this all here. So the slope is dy dx, and that's equal to y prime of t over x prime of t. And so this is going to equal, we know both of these, so sine squared of t over square root of t plus 2 over e to the t. So I'm going to simplify that a little bit. So let's make this. Let's flip the fraction, put e of t on the top, and put root t plus 2 on the bottom. Okay, so dy dx. Now we just have to plug in t equals 2. This equals, all right, so e squared times sine of 2 squared, and then divided by the square root of 2 plus 2, which is 2. So 3.055. Awesome. Yeah, so just plug in 2 for all the t's and you'll get that. Okay, so now we want to find the x-coordinate of the particle's position at time t equals 4. So how we want to do this is we're going to set up a start plus change problem. So we can find, we're trying to find x of 4, and so that's going to be x of 2, because we're given x of 2 in the problem. It's 1 right here. And then we add the integral from 2 to 4 of x prime of t dt. So we know x of 2 is 1. I'm going to put this part into my calculator. 2 to 4. Root x plus 2 over e t dt. And we get 0.253. And so we combine this together, we get 1.253. And that's our answer. Pretty simple start plus change problem. Let's write this down. Equals the square root of dx dt squared plus dy dt squared. So we know, so first we have to evaluate dx dt and dy dt at t equals 4. So t equals 4, that's going to be root 6 over e to the 4th. And then dy dt, that's going to be sine squared of 4. So let's plug this in. Square root, and I'm just going to square this out. So 6 over e to the 4 times 2, which is 8, plus sine of 4 squared is just sine of 4 squared, so it's sine to the 4th power of 4. And so this will equal, let me compute that on the calculator, 6 over e to the 8th plus sine of 4 to the 4th. And that's going to give me 0.575. And that's my answer. So then we have to find the acceleration vector. So now we have to find d squared x over dt squared, and then d squared y over dt squared. So first let's do d. So we know that dx dt is equal to root t plus 2 over e to the t. So now we'll use the quotient rule here. So we'll make this equal u over v, and so we have to do u prime v, so e to the t over 2 times the square root of t plus 2, and then minus v prime u. And so v prime is just e to the t, u stays the same as well, and then this will be all over v squared, so e to the 2t. And so then d squared y over dt squared, so if it's sine of x squared, we can just use the power rule to sine of x cosine of x, and that equals sine of 2x from the trig identities. So sine of 2t. So now we just have to evaluate both of these at t equals 4 to find the acceleration vector. So let's plug in this first one. So e to the 4th over 2 root 6 minus e e to the 4th times root 6 over e to the 8th. It's going to give us negative 0.041. So that is our x-coordinate, or x-acceleration. And now sine of 8 is just going to be our y vector. So 0.989. And boom. That's it for C. Okay, so now for the last question, what we want to do is find the distance, the total distance traveled by the particle from time t equals 2 to 4. So how we can set this up, distance d, we just integrate the speed, because the derivative of the distance is the speed. So we integrate this from 2 to 4, and then it's the square root of dx dt squared plus dy dt squared dt, and that's it. So I'm going to plug in some values here. So this will be t plus 2 over e to the 2t plus sine to the 4th of t dt. So now I'm going to put this into our calculator. Just going to get the answer. Alright, so what I got was 0.651. And that's our answer. Alright, that's it for the free response questions. I hope you enjoyed, and I'll see you next time for the no calculator free response questions.